reading glassware. Okay, we will use glassware more than anything else. So we'll be measuring volumes a lot more than anything else. We are in your note packets. All right, so when I start with notes, just get those packets right out. The biggest thing you guys got to remember, these steps, we're kind of this. I think it's page 11 in your packet. We'll kind of start there and we'll jump back. I know we skipped a page or two. You know that when reading glassware, you've got to determine the scale. The ruler activity we haven't done yet, so you guys will get a chance to do that in lab tomorrow. What's a meniscus? It's not the thing in your knee, right? Yeah, it's a curve. Now, it can be, I saw a lot of people going like this where it's lower. Some glassware, though, it can actually go upwards. Okay? Where do you read the meniscus? At the bottom, right? At the bottom of it is where you want to read it. So if it was an upward one, where would you read that, do you think? At the top, right? Because we're trying to get the volume, and in a liquid, it's going to be like this. This is showing most of the liquid. Now, some of it will adhere and kind of stick to the sides of your glass, which is what gives it that meniscus shape. But if we read it at the top, what do we have within that? We have air, right? Empty space that we're not really, it's going to throw our volume off. And you might think, oh, it's not that big of a deal, but with some of the work that we're going to be doing, guys, we talked about percent error. If your volume's off, every calculation from there that you use the volume for will be off as well. So it does matter. You want to err on the side of less than more. Now over here, on the right with this one, we can see that if this is filled in and it's going up, these little spots, they're less significant than what they would be with the one on the left. Okay, so we do read from the top. There's a little bit of extra space in there. It's very, very insignificant. Just like the amount that's on there, we draw it. When I draw it here, it looks like it's bigger than it actually is, so it's more insignificant. Right? And you estimate, right? Will two measurements necessarily be the same? Now, you and your partner will probably come together on a consensus, but you may see it as like 0.51. Somebody else may see it as 0.49 or 0.55. Okay, so you estimate that, the known digits plus the estimate. So what does that mean? This is something that people will tend to forget in lab, and I will take points off because you forget to estimate. Okay, so think about that as we go through these examples. So, take a look at that first one. What's our scale? What does each line represent here? That's the first thing you got to ask yourself. All right, so it reads to the tens place. Where are we going to estimate? 40. All right, so if we look at this, what'd you say, Michaela? 48. Somebody else? 47. Anybody else have anything different? Maybe 49, right? Notice, we know that the 4 is definite. Okay, so we're recording to the tens place for sure. It's this ones place that is the estimation, where you can have a little bit of wiggle room. So if you're asked on a quiz or a test to measure something, there's a little leeway. All right, the Regents exam does that as well, where there's some leeway because it's up to your interpretation. Okay, you got to make sure you show all the known digits, which is knowing the scale, and then you estimate one past it. So if we look at the second one, what does each line represent in the second one? 1. Okay, so how might you report this value? Heard 30? Heard 29? Neither of those are correct. You just ignored what I was saying to you before. All right, 30.1 would be acceptable. What'd you say? 29.9 would be acceptable. How would I write 30? If I thought it was on the line, how would I write that, guys, to make it acceptable? Yeah, right? So this is the one that people will tend to forget all throughout the year in lab. You, again, have to show that estimation. It's okay if you think it's right on the line. I would agree, it's right there at 30, but because our scale reads to the ones place, that gives us a certain level of accuracy and precision like we talked about yesterday. Okay? It lets us know, the number that we record lets us know how accurate the instrument is that we're using. So this is a more accurate instrument in picture number 2 than picture number 1. Picture number 1, we can only accurately read every 10 milliliters. In picture number 2, we can read every 1 milliliter, so it should have more precision when we report the answer. You always go the known plus 1 digit. Okay? If you think it's on the line, you've got to have a 0.0 there. All right, you got to include that 0.0. That's typically the only time when people forget to do that is if it's directly on like a zero line. You got to throw it in there, but you can't have too many. So this will take practice as we go through. Last one, what does each line represent? 1. So where should I report my final answer to? To the first decimal. So guys, put it this way. If it reports, okay, if it goes to the tens place, I'm sorry, not reports. We're going to change it up a little bit. So if it reads to the tens place, we will report to where? The ones. Okay? If it reads to the ones, we report to the tenths. 0.1. If it reads to the tenths, we report to the, right? You get that idea. So you always go one past what it's showing you. Okay? One past what it's showing you. Not all tools, all instruments, all measurement tools are going to be the same. So how might we report this answer here? This last one, number 3. Right? We can all agree that it's definitely 36. If you look here, this is the 36 line right there, and it's in between 36 and 37, so there's some wiggle room. I heard 36.8. I heard 36.7. You had 36.9. Even if you went all the way down, guys, to probably like 36.5, you probably would get, it would probably fall in that range, okay? Because it's, again, depending on the size and stuff with that, right? You guys go ahead, take a few seconds, answer all of those. They're called significant figures. So when we look at glassware, we look at any type of instrumentation, whether it's a piece of glassware, whether it's a balance, whether it's a thermometer, guys, whether it's a meter stick or some type of measuring tape. Each one of those numbers is significant, meaning they're important. Okay? Yesterday, we talked about the difference between a measurement and a regular number. What's the difference? What's one difference between a measurement? What does it always have? Unit, because it represents a what? A measurement which represents what? What does a measurement represent? Did it just happen? Did it just fall out of the sky somewhere? It's something you took. Somebody did something. It represents that action. So the thing you want to remember, guys, is you can only be as precise as your least precise measuring tool. Okay? So depending on what you have to measure with, it's going to dictate how precise you can report your answer. So all the numbers that can be known precisely in a measurement, guys, plus the last estimated number. That's what we were just talking about. That's what a significant figure is. Okay? I have a sheet here that I'm going to pass out. There's a hurricane right here, right? It's about to like just wreak havoc on the Carolinas, all right, where I was. Glad I'm not there anymore. Okay? I know that's terrible. I'm not an artist, so it's. That's about the size of it, too. I think that's to scale, so you can quote me on that. What ocean is that over there on the right side? It's the Atlantic, right? What does Atlantic start with? A. Okay? So, guys, this is just an analogy. If this analogy does not work for you, don't use it. Okay? It's okay. This helps some people. Some people are more logical. They don't necessarily need an analogy. This is just trying to get you guys to think of a map and starting which side we're going to start from. So, what's another synonym for not being not present? Absent. Oh, look at that. Okay. What does absent start with? A. So that whole analogy of using this Atlantic and stuff with the map, guys, is just trying to have you recognize absent, okay? Meaning not there. Okay? Now, on the flip side, where it's nice and sunny like all the time over here, okay? And it's like, cool 75 degrees like all year round. I didn't know that until a few years ago. Like San Diego, did you know it was like 78 all year round? It's crazy. Yeah, I guess. Maybe that's why people are happy out there. Anyway, what ocean's out there? The Pacific. Now, we don't have to do a synonym here, guys. P and P. Present and P. Now, you might be thinking, what are we talking about, present or absent? When we look at a number, okay, we're looking for decimals. So here's the examples. You guys have these examples in your notes. The first question you want to ask yourself is this. Is there a decimal? Okay. So we're gonna go slowly together, and we're just gonna count. We'll talk more specifically about rules in just a second. That's what that other supplemental sheet that you put in there. We'll talk about that in just a second. So, starting on the left side, is there a decimal in that number? Yes. So a decimal is present. The whole analogy here with the coasts and the oceans, guys, present starts with what letter? P. You want to think about Pacific Ocean. What side of the United States is the Pacific Ocean on? West, which is like, if you look on it left or right, it's what? So we're going to just start from the left-hand side. That's all that analogy's for. It's to help you kind of remember that if a decimal place is there, if you see a decimal, we're starting on the left side, counting our number. You with me so far? Okay. Now, once we distinguish what side we start counting from, that's where we're going to look at our rules sheet. Okay. So we're going to take a look at that right here. Here's our rules. Rule number 1. All non-zeros. So we might want to have a highlighter. All non-zero numbers are always significant, meaning important. You will always count non-zero numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Those will always count in your total of significant figures. So if you take a look, excuse me, in our example to the right, how many significant figures do I have in that first number? Count them up. 9. There are 9 sig figs. That's it. When you're asked to count them, you just count and see how many numbers are important. Every one of those numbers is important. So zeros located between the non-zero numbers are always significant. So if we take a look there, first number, 40.7. How many significant numbers do we have? 3. Now be thinking to yourself, which side am I going to start counting for? If the decimal's present, I start on what side? The left. If there's no decimal, I start on the all of these so far have had decimals in it. Actually, the first one did not. Okay? My apologies for that. So we need to ask ourselves that. 87,009 kilometers. Is there a decimal? Which side will we start from? How many numbers do we have? Now, up until this point, guys, has it mattered which side we've started counting from? No. Okay? These first two rules, it doesn't really matter. Okay? This is where we kind of start, it does matter where we start counting from. Number 3, for numbers that are less than 1, all zeros to the left are not significant. They're placeholders. Okay? Is there a way that I could rewrite that first number in that box, number 3? Could I rewrite that number right there? Yeah, how? You did this for homework. Exactly. We could write it in scientific notation where we just show the important numbers. Times 10 to the minus third, I believe. So guys, scientific notation automatically shows us all the numbers that are important. Okay? That's one of the great things about scientific notation. It shows us all the sig figs. If we write it out the long way, not every number is going to be important. Okay? So, because if we convert it to scientific notation, we can just use that, use the exponent as like that placeholder for those zeros. So if we take a look here, decimals present. Which side do we start counting from? The left. Decimal's there. Now, I'm going to cross out these initial zeros. Whatever side you start counting from, if you run into zeros at first, cross them out. They're not important. It's only the zeros that are between other numbers. Okay? Think about our rules we already talked about. Non-zero numbers are the ones that are important. If a zero is between non-zeros, that's when they're important. If they're on the ends, they may or may not be. How many sig figs do we have in that top number? There's 4 sig figs. You with me so far? Okay? If it sounds like I'm talking down to you, I apologize. Again, I'm just trying to bring you guys along slowly. Okay? You try the next one. Ask yourself, is there a decimal? Figure out which side you start counting from. Do I cross anything out, or do I count every number? Is there a decimal in that number? Which side will I start from? Left. Are these first zeros important to us? No, so I'm going to cross them out. How many sig figs do I actually have? I have 1 sig fig. All right. Rule number 4. Now, those were zeros at the beginning of a number, meaning beginning of where we counted from. Zeros at the end of a number are significant. So again, these two examples. Is there a decimal present in both of these? It should make sense that zeros at the end of these numbers are important if you think about it like a ruler or a balance for grams there. Those numbers show up in your number at the end of the balance. They're using those numbers, so they're important. How many sig figs will we have with this first number? Yeah, see, this is where it gets a little bit more confusing. We have 4 sig figs. All of the numbers there are important. It's only when you come across zeros at the start, before you get to another non-zero, that they're not important. So the second one, decimals present, start from the left-hand side. Every number. Once you start counting, guys, you count until you run out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sig figs. You still with me? Okay. When I give one rule, or like if a decimal's there, that's when things are, everyone's like, okay, I feel pretty good. This is where the confusion starts to happen. Okay, rule number 5. Zeros at the end of a whole number may be significant or not. If there's a decimal, that's what we're looking for. So it looks like we have the same number in both of these examples. Is this number the same? The answer is tricky. No, they're not the same. Okay? Here's why. That first one, is there a decimal? Which side do we start counting from then? The right. So we would come in this way. Well, I don't start counting my numbers as being important until I get to something other than 0. Cross these ones out. There's only one significant figure. What this means is that this number, this 2,000 meters, this has been rounded to the nearest 1,000. So whatever tool we use to measure it, it only records accurately to like the 10,000s place. So you round to the nearest 1,000. If we look at the second number, there's a decimal, right? Which side do we start counting from with a decimal? The left. Okay? I'm going to start counting right there. Those zeros are important now. How many sig figs does that number have? 4 sig figs. So what this second one shows us is that we had a much more accurate tool to measure. This has now been rounded to the nearest ones place versus the thousandths place. It's much more, there's a lot greater accuracy and there's a lot greater precision with that number. This is why significant figures are important. Throughout the year, guys, you will see why it's important as we take measurements and we do stuff in lab. Exact numbers have an infinite number of significant figures, like when we do conversion factors, which we will talk more about conversion factors, guys, in the coming days. So hold on to that one right now. We're not going to worry about it. I want you guys to go through and figure out with these 6 numbers that are at the top of your page how many sig figs each one has. We have 4 sig figs in 32.02. 42500, 42,500. How many sig figs do you think we have? 3. Which side did you start counting from? The right. Was there a decimal? No, so we cross those 2 out. They are insignificant. Okay. 620350. How many sig figs should you have? Yeah, 5. If you got 5, great. 75.620. How many sig figs? Should have 5 as well. 3625. Good. You with me so far? Not too bad, okay? Typically, guys, counting, everybody's usually pretty good with that. Tomorrow, we're going to talk about calculating. How do we calculate with sig figs? Okay? So, for homework, 2 things. This chart on your supplemental sheet, go through, tell me the number of sig figs. Try to figure out what rules apply to those.